So this is question number 3 on page 176. We didn't do inclined planes, which maybe makes this question a little bit easier to picture, but I think we can get at this question without doing inclined planes. And it actually probably makes it less confusing in the long run. So we have, so what do we have here? We have a 25-degree incline. So we have a ramp with a 25-degree angle. And we have a 65-kilogram athlete runs up the incline. So going up the incline, so the mass of this athlete is 65 kilograms, and the power is 2.50 kilowatts. So we want to find the time required for the athlete to run 20 meters up the incline. So we know the athlete goes 20 meters up that incline. Now, when the athlete goes up there, initially the athlete's changing their energy. Initially, the athlete has a potential energy of 0. Then the athlete does work over time, which is what power is, to get to this height where they have a certain amount of potential energy. Now, potential energy is mgh. We know m, that's the mass. We know g, that's 9.81. We do need to know the height, and so that's where this triangle comes in. We do need to know how high that athlete is off the ground. That's the height. So we are going to use the sine of 25 degrees is equal to the opposite side, which is the height, over the hypotenuse, which is 20 meters. So sine of 25 times the height of 20 gives me 8.45 meters is how high that athlete's off the ground. So the potential energy at that point is 8.45. I still have all those digits, times 65 times 9.81 is 5,389.6 joules. I'm keeping all those digits. So that's the potential energy. Now, if you think about potential energy and how it's changing, right? Potential energy is 0. Now we have potential energy. So there's work that's been done. And that work is equal to the change in potential energy, which is that amount. So that allows me to maybe find the time now, because I know that power is my work over my time. So I know work and I know my power. So time will be my work divided by my power. So I have my work here. So my work is just my change in potential energy that I have from before, divided by my power. So that's 2.50 times 10 to the 3 watts. So I put that in my calculator. So 2.5 times 10 to the 3 is 2.16 seconds. So here we go. Consider the world-class sprinters can run 100 meters on level ground in 10 seconds. Is your answer from part A reasonable? So this is 20 meters. So if I go times, so 20 meters is that many seconds. So if I times it by 5, it would be about 10.78 seconds. So if I were to go 100 meters up this incline and able to put out that same amount of power, that would be 10.78 seconds. So whether it's plausible or not, that's maybe for you to decide. This seems like a very athletic sprinter. If they continue at that rate of power, they're going up an incline and actually they're still going relatively fast. So you decide with that one, but that's kind of how you would compare those two numbers.